Hi, my name is Julia Wester, and I'm here today to talk to you about transforming project forecasts with probabilities. But I want to introduce myself just a little bit so that you can know why I'm here talking to you about that topic. Like I said, my name's Julia, and I'm the co founder and CEO of a Swedish company called 55 Degrees. And at 55 Degrees, we make apps that help make it easier to get your work done. That's from refining your work to bringing external data into Jira to improving your workflows and creating reliable forecasts. So I spend a lot of time talking to people about their data and using their data to make forecasts. And I'll be showing you some screen grabs of the products here. But what I want you to know is that even if you never use our products, everything that I talk to you about in this talk will still be beneficial to you. So you don't have to use our products to get a lot of value out of this talk, but it sure does make it a lot easier. So where we need to start, especially when we talk about forecasts, is we need to discuss the elephant in the room, certainty. We like to think that our forecasts are certain, at least the people that we tell them to just assume that there's a certainty behind the forecast that we give people. But it's not a new thought that really there's not a whole lot in this world that's certain, except maybe death and taxes, as Benjamin Franklin pointed out. But when we give people forecasts, whether in a Gantt chart or some other way, people interpret, they fill in the blanks with certainties because they see this picture and it doesn't tell them any information about the risk associated with getting that forecast completed. So because we don't tell them otherwise, they fill in the blanks that, okay, there's 100% certainty this is going to happen. No matter how well we do our job, we cannot get rid of uncertainty when it's inherently present. Now, there's a book called The Art of Action by Stephen Bungay. It's a really good book, and it helps us dive into understanding why certainty in many cases is outside of our reach. We like to think that there's a simple circle that if I want these outcomes, I can make these really excellent plans. And in those plans, I outline some actions. And then I get people and they do the actions that I outlined. And then if they do the actions that I outlined, I'll get the outcomes that I wanted. But the uncomfortable reality is that that's rarely ever true. If that were true, we wouldn't be here listening to this talk today. We'd all have perfect project plans that went off without a hitch. But here's what happens. Here are the three gaps that get into our way. Between our ability to identify outcomes and make plans, there's a knowledge gap. There's a difference between what we would like to know and what we actually know or what we actually can know. Even if we researched and researched and researched, there are things that we will never be able to know in advance. That means that we can't create the perfect plans. So right out of the gate, if you agree with this, that this gap exists, you know certainty is out of the window. But let's say it wasn't. Let's move on to the next gap. Even if I could make a perfect plan, the alignment gap gets in my way. Now, this gap is the difference between what we want people to do when we outline those actions and what they actually do. Because if we could program people, they still may behave in a way that's unexpected because we're not all carbon copies of each other and our brains work differently and we have different capabilities and different understandings. So if you've ever seen a requirements document and given it to 5 people and they interpret it in 5 different ways, you understand the alignment gap. Okay, so if you agree that the alignment gap exists, we can't plan our way out of uncertainty. But let's say we could conquer the knowledge gap, we could conquer the alignment gap. Then that third gap gets in our way and really just knocks us out of the park. And that's the effects gap. That's the difference between what we expect our actions to achieve when we do them and what actually happens. So if you've ever done something more than once and gotten 2 different outcomes, all other things being equal, you know that you can't always control your environment. You can control maybe what you do, but you can't control the pieces that you interact with because we are in systems dealing with systemic things. So we have to agree that we can't plan our way out of complexity. Now, even though we intellectually know that, the first thing that we do when a plan doesn't work is that we do it harder, right? And here's what the workplace version of doing it or ruling it harder looks like from a project planning perspective. We might start off with something simple and that doesn't work. And then we're like, well, we just needed to do this better. So we're going to do all the work breakdown structures. We're going to get people to spend hours of time thinking about exactly what they're going to have to do. We're forgetting all these gaps, by the way, and spending valuable time and money that we really don't have trying to make a plan that's still not going to be foolproof. And all of these plans that we spend so much time and money on end up being what we call a deterministic plan or a deterministic forecast. And the determining factor about that, the identifying factor, is that it communicates a single possible outcome. We know that many are present, but it only tells us one. So it'll be done by X date, right? Or on X date even. But we don't tell people the likelihood that that will occur. Is that 100% guarantee? Is that only 20% likely? We don't know. This kind of forecast should only be used when you can be absolutely certain, which is hardly ever the case in our kind of situation. Instead, what we need to do is move to something that helps us understand risk. We can lean into the fact that we have uncertainty instead of fighting it. We can embrace it and we can start learning to talk in probabilities. And a probabilistic forecast has two components. It has a range of outcomes and the probability that you'll fall into that range. So the example on the left has both of those pieces highlighted in blue. There's an 85% chance, that's the probability, that this will be done on or before a given date. So the range of outcomes from today till that date are all possible. And there's an 85% chance that it'll fall into one of those outcomes. Now that means there's a 15% chance that it'll be done after that date. And you can express that as well. Now, we need to talk about probabilities whenever uncertainty is present. So if there's more than a single possible outcome, we should learn to talk in probabilities. In this talk, we're going to cover how to create multiple types of probabilistic forecasts. There are two basic types. There's your single item forecasts. That's when you have one thing to do and someone's asking you, when does their thing get done? And then there's the multiple item forecasts, when you have a collection of work that needs to get done and you want to know when that collection of work is going to finish. Right? So think about your project dates, think about your release planning, your sprint planning, anything where you're trying to forecast when you're going to finish multiple items. And in that multiple item forecast, there are two subtypes. We have fixed date. So how much can we get done by a given date? And then we have fixed scope. We have this amount of work. When can we get that set of work done? So we're going to cover how to create both of those with some very simple data. We don't need different types of data for each type of those forecasts. For all of those, all we need are these three pieces of data. We need an issue or a work item to finish, and then we need to know the date that it started and the date that it finished. So you have to define start, and you have to define finish, and then you need to track the dates at least when it moves across the start and the finish line. And if you collect just those pieces of data, whether it's manually through a tool, you can do everything else that I talk about in this talk. So knowing that, let's dive into our single item forecasts. Essentially, when we're talking about when will it be done, we're asking how long will it take for this single item to go from the start point to the finish point. Now, the way that we're going to measure that, the data that we're going to use, is a metric called cycle time. Okay, you may hear other names, flow time, lead time, etc. I'm going to use the word cycle time. And my definition of that is the total elapsed time, total calendar elapsed time it takes a work item to travel from start to finish. Because let's face it, our stakeholders, the people who are waiting on our project to be finished, want to know the calendar date it will be done. They don't want business days, they don't want to have to do addition back into the number of days you give them to figure out which calendar day it will finish on. So we're talking total elapsed time here. Now, the way that the actual calculation that we use to get the cycle time for an individual item is simply to take the finish date, subtract the start date, and then add 1. So I'm including both the start and finish date, and I don't leave any days out. This also means that if something starts and finishes on the same day, you'll always have a value. It'll be 1 day. It took you 1 day to get that all the way from start to completion. Okay. Now, I'm showing you a picture from Actionable Agile. You may use other charts that are equivalent, but in Actionable Agile, we have a cycle time scatter plot. And what that does is it lets us plot the date that any item or items finished. Each one of these dots is one or more items that finished on a given day, and that's plotted along the horizontal axis of when it finished. And then it's plotted along the vertical axis to show the cycle time. So you can see that there was one item that took north of 40 days to finish, and many that just took a couple of days to finish, and everywhere sort of in between. But how do we get from this scatter plot, literal scatter plot, to understanding how long does it take to finish a single item of work? Well, we can do some simple division. Okay, so let's say there's 100 dots on this chart, and I want to know the average, the 50% probability that it will take me to finish an item of work. I want to be able to say 50% of the time we'll finish work, in this many days or less. So if there's 100 dots, I just count up from the bottom to find where the 50th dot is, and I draw a line across where that 50th dot lies to see the cycle time that it lands on. So in this data set, 50% of the items finished in 7 days or less. Okay. And I can continue counting to any other percentage I want. In Actionable Agile, we have these 4 already sort of carved out for you. And I can see at a glance, just on loading this data, that 85% of our work took 16 days or less. Okay. And so that may be enough for you, right? To know how long it took you to finish your past work. We'll talk about a little bit of rule of thumb about when that can be taken, at a high level of truth, and when you might need to use that with a grain of salt. So your next question might be, well, how do I choose the probability? How do I know when I should go with the 50%, the 95%, the 70%, or any other percent you want to use in between? Well, the way that you do that is you think about the tolerance you have for risk. So let's think about it. If I were to give you an estimate or a forecast based on a 50% chance, that's saying, well, I'm going to be wrong as much as I'm right. And what they say is plans based on average fail on average. They succeed on average, but they fail just as often as they succeed. Okay, so that's probably never going to be the one that we go with. But how do we decide which one do we go with? Well, the question you should think about is, what happens if we fall on the downside of our probability, if we fall on the downside of the bet that we're making, essentially? So if I were to say 85% of the time, we're going to finish work in 16 days or less, what's the risk? What's the fallout when I hit the other 15%? Is it okay for 15% of our work to have that consequence? Okay. The more certain you need to be, the more outliers you have to contain. And if you try to fake near certainty. If you try to get close, we say you can't have 100% certainty, but can I have 99, 98? You're really sort of still fooling yourself that your forecast is going to include every possible outcome you've experienced in the past. That can be as useless as saying, oh, there's a hurricane going to hit and it's going to land somewhere on Earth. It's so wide as to be a little useless, right? So unless you have an extremely tight predictable system, which if you're starting out, you probably won't have. So be a little honest with yourself and pick a tolerance that's not too forgiving, because if you go too far out, it's going to have a huge range and people are going to get upset that you're often overestimating how long it's going to take you to get work done. So find the place that's just the right balance. Then once you do that, we want to use the right language to deliver our forecast in a probabilistic way, because a probabilistic way helps us understand the risk associated with that forecast. So if I say 85% of the time, we're going to finish a work item in 16 days or less from the day it starts, that means 15% of the time it won't. And in that 15% of the time, it's going to take 17 days or more. But I'm also not saying that will always take exactly 16 days. I'm saying that it will take anywhere from 1 to 16 days. Okay. And if I don't like that range, I can do other things that we won't talk about in this talk to help bring that range down, so you'll be happier with these forecasts. Now, that underlying rule of thumb that I told you I was going to talk about. Now, you might say you'd heard that past performance is not indicative of future performance. In some cases, that might be true. Here's what I want you to think about it. The underlying rule of thumb is if the conditions that your team or organization experienced when they generated this data, when they finished that work, if those conditions are roughly the same, so same capacity, same skill sets, same everything, then you should be able to use that data to forecast the period that you're trying to forecast. So if the conditions that you had in the past roughly resemble the conditions for the period you're trying to forecast, your data should be thumbs up, A-OK, right? Another way of saying that is, this is what we've been able to do so far. What have we changed to think that we're going to experience a different outcome? Okay. Things don't need to be exactly the same. They just need to be roughly the same. Okay. That rule of thumb applies to all of the types of forecasts that I'm talking about, even the multiple item forecast that we're going to get into right now. So if we go back and we think about our process, and we knew that single item forecasts are based on cycle time, that time it takes for individual items to move between start and finish, our multiple item forecasts are asking a different question. They're asking, when will all of these items be done? So we're going to need a different metric, still only using those 3 small pieces of data. We're going to need to have our throughput metric. Now, this is the total count of items that pass your defined finish point in a given period of time. So maybe 1 per day, 6 per week, etc. It doesn't matter what unit of time you use as long as you're consistent. In Actionable Agile, our default is day. Now, you can use a throughput run chart that will show you your throughput data. And you could even say, hey, 85% of my days have this many items or more finished. But that's just talking about a single day. And often if we're trying to do a multi-item forecast, we need more than 1 day, right? So we need a little more help. We need a Monte Carlo simulation to help us calculate the probabilities. Now that sounds scary, but it's really not. Of course, there are many places where you can get a Monte Carlo simulation. It's not something that we came up with at 55 degrees. There are spreadsheets out there that you can find. But in Actionable Agile, we have Monte Carlo simulations that can take that throughput, the rate at which you finish work. You can put in some simple answers and get probabilistic forecasts in seconds. So we talked about that there were 2 types of multi-item forecasts. The first one is fixed scope. And so essentially we're asking, when will this specific set of items be done? So we have a chart called the Monte Carlo win simulation. And you can see in the right column here, I've outlined 2 questions that you have to answer to control the simulation. You always need a start date. It can't know when you're going to finish unless it knows when you started, sort of like your GPS. Okay. Now, the second question you have to answer, because this is fixed scope, is how many items do you want to complete? So I have 45 here. You can even put a range in if you're not quite sure. So if we put those numbers in, it immediately runs 10,000 trials. And you can see in the calendar here what the likely outcomes are. When are we likely to finish that amount of work? And we have a color-coded legend, so I can easily look at and see there's an 85% chance that we'll finish these 45 items on or before May the 25th. Okay, so that's how we would look at that. And if I wanted the 95%, I would say on or before May 29th, et cetera. Now, if someone wants a different outcome, you can look and see what likelihood that particular date is. And then you can have all those normal project management conversations about, well, what can we change to make this possible? Fixed date is almost exactly the same, just one different input in the simulation control. We're still using our throughput, but instead of giving it a number of items, we're giving it an end date. So we put in the beginning date and the end date. So we have this set amount of time. How much work can we finish? Okay. Then we choose which probability we want to use. So I've selected 85%. And then we can look and see that there's an 85% chance that we can finish 67 or more items by the end date that I put in. So doing forecasts is literally that simple. And what these Monte Carlo simulations have done is run thousands of simulations of you doing that project, you doing that fixed scope, you running through that specific time frame to see what you're likely to do based on what you've done in the past. You know, they say that if you don't know what's going to happen when you do something, one of the best things you can do is to do that thing over and over and over again to see all the possible outcomes and then understand the probability. Like if you don't know the likelihood of flipping heads on a coin, you can flip it a lot of times and do the math. Well, that's what these charts are doing. Your cycle time scatter plot has tracked you doing single items over and over and over again. The simulations simulate you doing this collection of work over and over and over again so that you can get the probability of all the possible outcomes that you're likely to have. If you have an entire portfolio, you can use a tool that we have called the Portfolio Forecaster that takes your epics or versions and does all of the Monte Carlo simulations using throughput you outline, and it'll give you the likelihood you'll finish things by a due date or when you're likely to finish something based on a given probability that you choose. So I want to summarize here a little bit. If you could only take a few things away, here are the things that you should take. When more than one outcome is possible, you have to use probabilistic forecasts because they show risk in 2 ways, the likelihood of an outcome and the range that of all the possible outcomes you can get for that probability. The probability you choose should match your risk tolerance. And there are tools like 55 Degrees' Actionable Agile and Portfolio Forecaster that can help you create these forecasts in minutes without even needing to be a math expert, much less a statistician. If any of this is interesting to you, please join me at the after party, the European after party, and I'm going to be giving demos of Actionable Agile, Portfolio Forecaster, and more, and you can ask me questions about this topic. I also want to let you know that because you watched all of this way, you deserve a treat. So if you go to pm72.55degrees.se and you sign up for our newsletter, after your free trial, you'll get 3 more free months of our apps on the Atlassian Marketplace. So give it a look And I hope to see you at the after party for questions. Thank you.